Hey, we have a question here. It says you have 400 feet of fence to enclose a rectangular region. You will also use the fence to divide the region into 3 equal parts. What dimensions will create the region with the most area, and what is the area? So pick out some things here we know. We know how much fence we have, and we know we're going to divide into 3 equal parts, and we're looking for dimensions, and we're also looking for the area. So let's kind of draw ourselves a little picture here. So we're doing a rectangle, which I'll do my best to draw, that looks like this. And it says we're going to divide into 3 equal parts. And just do your best to make that happen. Okay? And you can draw this picture several different ways. And maybe it doesn't look equal, but honestly it doesn't really matter where these dividers are in terms of the problem, as long as they're parallel to each other here. So let's see here. The thing that we want to do is we want to create a quadratic equation, kind of like an ax squared plus bx plus c, to kind of help us out here. So we're looking for an area, and think of area as length times width. But these are very specific, so let's just try and make ourselves at home here. We need some variable in here, and it doesn't matter if it's the length or the width, but let's just take this width here and make it x. And if that's the case, all across here are these x's. And then let's take the other dimension the other way and make them y's. That could be our length. So length times width would be our x times y. But that doesn't really get us anywhere. What gets us somewhere is taking this 400 feet of fence that we have and adding up everywhere we use the fence. Okay, so this 400 fence is going to be used to make 4 sides of length x and 2 sides of length y. So it's not too bad to, in our formula length times width, to call one of these x or one of them y, but we need to get it in the same variable. So what I'm going to do is I'm going to isolate this y down here. So let's see what that looks like when we get there. So I'm going to move the 4x over. So 400 minus 4x equals 2y, and I'm going to divide by the 2. So y is going to be equal to, if I divide everything by 2, 200 minus 2x. So instead of calling this thing y, we'll call it 200 minus 2x. And what we did was we created a relationship between x and y based off of the fact that we had 400 feet of fence. So if we make y longer, that definitely makes x shorter. Or if we make y shorter, that makes x longer. So they interact with each other based off of that total amount of fence and how we set up the regions. So now our area, which can be a function of x, will be the length, which is 200 minus 2x, times the width, which is x. Okay, you don't need to take account all these divisions when adding up the area, but you do need to take these dividers into account by dividing up that 400 feet of fence. So we'll clean this up a little bit. A of x for area of x equals, we'll rearrange it as well, negative 2x squared plus 200x. So we have a formula, a function, that when we decide what we want x to be, it automatically calculates y for us and gives us the area that would enclose. Now it definitely has some parameters if you think about a function, because you couldn't make it more than so much or it wouldn't make sense. But when we talk about the word up here, the most area, that's a maximum. So if we think about the maximum of something, as far as a quadratic, that's a vertex. Okay, so that term right there is for the vertex. So basically we're finding the vertex. And that's where x equals negative b over 2a. Well, my b in this is 200, so negative 200 all over 2a, which would be negative 4. So the x is 50. So that's telling me that all these sides in here are 50 feet. Now you might be able to figure that out with some trial and error on your own, and I'm not going to knock you for that. But if I ask you to show me some work, you're going to have to show me the appropriate way to do this, because not all problems are going to be easy to figure out in your head. But that's just the x part. And if we came back here and put that in for x where we had y solved for, we would figure out that y would be 200 minus 100, 100. So this side down here will be, let me find my green marker, 100 feet. So the dimensions is 50 feet by 100 feet. And it's kind of important that we know that that's the way it's going to work. Now 50 by 100 is definitely going to give us a nice total area. But if you build it wrong, if you try and make 4 sides of 100 and 2 sides of 50, you don't have enough fence for that. But 50 times 100 is 5,000 feet squared, I believe. So in the case of building the function, we looked at all the information we had and we built a function in terms of one variable. That gave us the quadratic, and since we were looking for a maximum, that led us to thinking about the vertex. Okay, so the dimensions are 50 by 100 and the area is 5,000 feet squared.